Hi guys, welcome back to the shop. Hey, today we're going to get back on the TS400 crankshaft. If you remember, I got this one into the shop a couple months ago, and the owner was trying to get the bearings off, and he slipped and hit the crankshaft sealing surface. So what we're going to do is what I've done on a couple others. I'm just going to cut down the shaft, and we're going to build a sleeve, press it on with about 2/1000 interference fit, and with some Loctite product. I think in this case we use 609, which is for press fit. So we'll be taking, let's see here. I'm going to take about a 1/16 of an inch off at around 62,000, something like that, and we're gonna put it back on. We're gonna press the new one on, and then we're gonna cut it down to size from there. The sealing surface is actually about right at 1,000 smaller than the bearing surface on this crankshaft. So it'll just be a transition from that to the other. It shouldn't be a big deal. The ones I've done before have always been the same size at the sealing surface as it is for the bearing, but I think anyway, I believe they were. It's been a while for both of them, but it's different on this one, and I'll show you before we start. So anyhow, geez, it's 30 below zero today, and there's nothing better to do when it's cold like that and work in a warm shop and repair a crankshaft. So let's get over here. I'll show you what we're doing and how we're going to do it, and then we'll get started on it. Okay guys, here's the damage right here, and I'm gonna take a still of that so you can see it. I don't know how good it's going to show up on the GoPro here, so let me take a still and I'll put that in now. Okay, so this is I've got this pretty well centered up, and just to show you what I'm talking about here, here's the bearing that we took off of this, and pretty much to this point right here is where the difference is. See, this slides right up to there. And let me get you turned. There we go. All right, so you can see. So that's just about where it stops, and that's where where it starts getting to. Let's see, the diameter there is 1.180, and this here is just a 1/1000th less. So that's your press fit for the bearing. So we're going to try to stay out of that area. I want to stay into the full seal area though. So what my plan is to go, because I believe right here is where the lip ran, the back lip. So I'm gonna go right to about here. This is where pretty much that starts. So I'm just going to kind of split the difference between what I think here is the seal area, and you know, this is right on the very front of that seal area. You can kind of see there's a little bit of pitting right here, and that's probably just outside the seal is what I would think. So if it were mine, I would probably try to just run it without that, but he wants it fixed, so we're going to do it. But this is, I don't know. I think I would just try it first. If it didn't work, then I'd do it. But I understand, you know, he's wanting to completely go through the engine, so you don't want to go and, you know, put put your engine back together and then find out that it doesn't seal. So we're going to do the right thing here and get it fixed up for him. Now, I've already measured, and from we're 1.441 basically from the flat portion of the crankshaft back here to where the taper starts here. So we'll have to trim this up at the end, so we want to try to keep that in the same area. And like I say, we're just going to go back here just a little ways, kind of split the difference. You don't want to be right over where the seal is going to be where you split. So we'll try to get back just before it starts your other thousandths up. And so we're going to cut this down to about 1.052. And then we'll take a piece of stainless steel, 303 stainless steel, and we'll bore that to 1.050. So that'll give us 2 thousandths interference fit for that to go up onto there. So I guess at this point what we need to do, I'll show you my what I've come up with here as far as getting it centered up. Well, I'm gonna have to move you here. Okay, I'm up here on the sealing surface and we're just pretty much zeroed out there. And we just move up onto the bearing surface just for, oops, it may not be high enough to do that. Yeah, I think so. Probably won't be now though. Yeah. Okay, let me go down here and then we'll come back. This just at the very bottom of the taper. And there's just a slight deflection there. About a half thou. And what I did was I came up this way, but see you've got these holes here, but I put a flat foot on here and tried to keep it up here. Well, let me go ahead and do that and I'll show you what I did. Okay, up against here now, that's really the only place we can gauge this. I'm not sure if you can see the dial indicator at the same time. Maybe that helps. So you can see we've got, we're getting the results of these holes as we go across here. So we're probably at about 2 thousandths, but it's showing up good where I'm at, and I've just got a very little deflection down here. So I think I'm going to go with it because I've been battling it back and forth, and I think we're to a point where we've got to accept what we've got, which is good enough. Like I said, let me grab my other foot here real quick. It's just hard when you've got holes like that. You've got so much that you have to just kind of assume, and we don't like to do that. But I do want to be right here. Okay, so we've got just some slight deflection there, about a half thou. And I go down to the seal area, and I'm trying to stay away from the damaged area. and it's actually a little better there. And then down at the taper, just beyond the key, and we got about a half thou. So I'm good with it. I'm satisfied this is probably from here, but I'm good where I'm going to cut, so I'm going to leave it alone. And when we come back in, the seal is flexible, so it's going to conform no matter what. And since our bearing area is different, shouldn't be any problem at all. Okay, that's how far down we're going to go. It's cutting really good. It was a little hard going through the first one, but see, we've already removed the damage to the end, but we've got to get something back in there. So let me continue on here. I'm getting real close here. Okay, right on target, 1.052. So now we'll pull this out and we'll start working on the sleeve, and we'll be making that to 1.050. And we'll go ahead and get this out. Then we can start on our sleeve. Okay, got this one zeroed out here pretty good. It's not real important to be that way, but this is our 303 stainless, and I believe this is the piece I used the last time I did one. Probably, oh gosh, I think it might have been the Yamaha 250MX. Can't remember, but this looks like about the same deal here, so I'll go ahead and get me a drill bit and we'll get started drilling. We're at about 10:36. We'll get in there and take another pass, and then we'll get the micrometer out and make sure we stay up on it. Need about 7 thousandths. This should be 6. Right on the money. That should be good. So all we need to do now is just cut it to size, I think, and then we'll take it over to the press and hopefully it'll go on there. Let's get this little chamfer down here so it'll more likely seat against the other piece. I think that's good. Okay, I think I'm going to do it right there. That should be just about it. Okay, let's get all this cleaned up and ready to go. All right, Loctite. And a little on the inside of this piece. All right. Guess it's time to see. I think that's down all the way. I'll give it just another push. Looks good, I think. It's kind of hard to tell where it goes together. Okay guys, there's our sleeve installed. I'm going to let that set probably till tomorrow, and then we'll put it back in the lathe and trim this down to size. And this end here is 1/1000th below this one. That helps you get the bearing started, and it makes no difference to the seal. It's pliable. So far, I'm happy. Looks like about like the last one I did. I've made it quite a bit longer here. I'd say it's about that much too long. Maybe 3/16 of an inch. But we'll trim it back and then taper it back into the taper here, and go ahead and trim this down to size. All right guys, got her set back up here. There's our 0. Got a little fluctuation there, just like we did before. Here's where we're going to be cutting right here on our new sleeve. And we've got, of course there is going to be a little bit there. We got about a thou. But we go to the bearing surface right in front of it. And there's nothing. Got a little bit out here on the end. Just not going to worry about it. I think we're close enough. So first thing we're going to do is we're going to come in here and take whatever off of the front that we can, and then we'll start peeling it off. Okay, I've got it back there just about to the where it's going to stop, right in here. I can see the taper, so we're going to start on the outside portion here. .2017. And of course that's 1.1812. So a little over 20 thousandths we've got to come down yet. It's getting close. All right, I think we're pretty close here. Okay, we're at 180, 1.184. And this up here is at 181. Yeah, 181. So we're about 4/10,000ths beyond where we need to be. So we're going to start with the with just some crocus now. I can't feel with my fingers the transition anymore, so it's just right on it. So I'll have to work this front little bit here a little bit, and then we'll work this here just with some crocus to try to get that smooth and down to the, it doesn't really have to go down all the way. I just need to be able to get that bearing on. Let me grab that real quick. And we're just about there. It'll wiggle on there. So we'll take that down a little bit more, just with some sandpaper and some crocus. Yeah, we're down to about 2/10,000ths now. Let me work on that a little bit. We'll try to blend it. You can kind of see the transition line there. This is where the, let me get a pointer here. You can kind of tell right there is where our sleeve went up, and here's where the next thousandths is for the bearing press, right there. So let's check the bearing now and make sure that does what it's supposed to do. There we go. And it stops right there and presses up on up to the shoulder there. I'm happy with it. I think that's going to do him good. That's a good repair on those. Stainless steel. Never rust there again or corrode or anything. Can't say the same thing about up here, but normally if these things get a little water in them, it comes down here and sets against the seal, and that's where it corrodes because it can't get out. So that's usually about that much. That's how you find a lot of them that have had water get in the crankcase. So that's good repair for him. Okay guys, that's all we can do. Okay guys, there you have it. We got the repair done on the snout, and I'm real happy with it. Looks like it turned out pretty good, and our bearing will go up to there, and that's where it's 1/1000ths bigger for your interference fit with your bearings, just as it was before. So that's a good repair. We'll be getting to the build on this pretty soon. There won't, the owner wasn't able to come up with, oh, what was it? Bearing, I think. Or no, maybe we got the bearing. I don't know. We couldn't find a rod. The rod is okay. I know we've got a pin and new thrust washers. So we'll be using all the stuff that we have. I just can't remember what the deal was on the bearing. Let me see if I can figure it out real quick. Okay, no, we couldn't come up with a bearing. We've got a new pin, and there's absolutely nothing wrong with the rod. It looks great. So we'll clean it up, and we're just going to have to go back with the old bearing, the old rod. We got new thrust washers and a new pin. I guess they're just really hard to find. I believe when I was looking at the Pro X, I was able to come up with a bearing there, but it would be, I believe it was a little bit narrower. So we'd have to do like we did on the Yamaha 250MX and make larger thrust washers, thicker ones. So, I just don't see any need to go through all that. This thing was running okay. It probably would have run for a long time yet, and I just don't see any point in not putting it back together, because the parts just aren't out there. That's just kind of what you're going to have to deal with. There's no wear on the pin. You can't even get your finger caught on any of that. So, you could do that, but we'll go ahead and put together what he's got. So we've got a pin and new thrust washers. So that's what we'll do, and hope for the best on everything else. I'm satisfied it'll be just fine. Okay, there you have it. We got our TS400 crankshaft repaired, and look for the buildup of that and the buildup and the check coming up soon. You know, we'll be putting it together, we'll be measuring everything, we'll be showing the run out on the lathe. This has got good points in it for our lathe, so we should be in good shape to put that back on there. We checked it all there when we started, and it was in good shape. We were right at 70 millimeters on the width, so we'll be putting it right back to right at that. That way we know it'll fit in the crankcase. And all the measurements at that time were great. We had run out, you know, hopefully we can get it a little closer than that. It was at about 2.5 thousandths on run out, and the big end clearance was well, it's supposed to be 6 to 20, and the small end can't exceed 0.118, and those are all in inches. Yeah, looks like, yeah, we had, the run out was 1.5 thousandths on the mag side, 2 thousandths on the clutch side. So hopefully we can get that good or better, and this thing will run for a good long while yet. The key is just, you know, I don't care what they say. I'd rather have a little extra smoke than a problem. So I always run my stuff a little bit on the rich side. I don't want hold pistons, I don't want scored piston rings or pistons, and I don't want wore out or seized crank pins when you can't get them. So that's my thought on it. Keep it a little rich, it'll live a long time. So hey, thanks for going along on the ride, guys, and we'll see you next video.